When you study the antiderivative and indefinite integral, you use the simple power rule to deal with every single problem, but sometimes the simple power rule doesn't work. So when the simple power rule doesn't work, we have to think about the substitution rule. So the substitution rule has another name that is called the U substitution. So let's take a look at these two integrals. The simple power rule is not applied when we integrate this kind of integral. So the integral of 2x times the square root of 1 plus x squared dx, or x times the square root of 1 plus x. So if you try to apply simple power rule, that is not going to work. First of all, the integrand is a product of two functions, right? So for the first function, if you use simple power rule, what is the first thing that you should do? You don't know, right? So in these two problems, using simple power rule is not going to work. So what is U substitution? So I have the U substitution in the next line right here. So this formula is actually for the U substitution. But if you read the formula, you have the integral of f of g of x times g prime of x dx that is equal to capital F of g of x plus c. So if you just look at the f, the g, the x, that looks like a lot to take. But how about this? I will solve the first integral. I will use the first integral to show you how to do U substitution. Alright, so first thing first, in the integrand, you have 2x times the square root of 1 plus x squared, right? So when you use U substitution, look for a composition function. What composition function do I have right here? The composition function is the square root of 1 plus x squared. We have a 1 plus x squared, which is a quadratic function, right? Inside a square root function. So we have a function inside another function. So therefore, I would like to let the u be that function. I would like to let the u be 1 plus x squared. You can call this the inside function or inner function. You have 1 plus x squared inside a square root function, and I want to let u be the function. And then the next step, you go ahead, take the derivative of u. So you just bring the 2 down, right? So 2x dx. All right. And then what else? Now, the next step is I would like you to isolate the dx on one side. So that means you have to divide both sides by 2x. So that will be 1 over 2x du equals to dx. So that is the 3 basic steps you have to do for U substitution. If you think the second line is too much to interpret, we can go this way. So let's say U is equals to 1 plus x squared. So you take the derivative of U with respect to x. So you write like this, the derivative of U with respect to x, that is equals to 1 plus x squared. And then you move the dx to the other side. So du is equals to 1. You take the derivative of that, so that will be actually I should not write that anymore. I should just write a 2x. So you have a 2x times dx, but if for a little bit of practice, it is easy to just write it like this. Now, why do we have to isolate the dx on one side? Look, back to the integral. We have dx right here, right? What is dx equals to? Dx is equals to this. So what you have to do is you have to replace the dx with the 1 over x du. Let's see what do we get. We have the integral 2x, and then the square root of 1 plus x is now a u, and then dx is replaced by that, and then du. Pay attention to this. Now, as you can see that these 2x can be cancelled, right? So at the end of the day, you have the integral of square root of u, which is u to the 1/2 du. So now you are able to use simple power rule to integrate. We just change the dx from du. We just go from dx to du. What is this process called? This process called U substitution, and or you can call this change of variable. Change of variable. We just change the dx to a du. Now, one thing that I have to remind you, and I want you to write this down, after you clean up the x, there should be no more x in the integrand. Let me say this one more time. The integral is now du, is a du integral. There must be no more x in the integrand. Let's do this again. The integral is a du integral. There must be no more x in the integrand. All right, so, and then you integrate that. So that is, what is that equal to? That is equals to u 1/2 plus 1, and then 1 divided by that, and then you plus c, right? Okay, continue. So this is a u to the 3/2, right? And then this is the inverse of that is 2/3, and then you plus c. Are we done? The answer is no, we are not. You still have to recall that u is equals to 1 plus x squared. So at the end of the day, you have to put the u back to x, which is 2/3, and then you do a 1 plus x squared, and then raised to 3/2, and then plus c, and then this is the solution that you are looking for. That is how you do a u substitution. There is one special case, and I am going to show you that right now. So that special case, let's take the other integral, the integral of x times 1 plus x. So we have the integral of x times 1 plus x dx. So this one, you have 1 plus x inside a square root, you let u equals to that. And then you take the derivative on both sides. So that will be just 1, right? And then dx, and then you divide both sides by 1, so you have du equals to dx. And then you do a substitution or replacing the dx. Oops, there is a little mistake right here. That one is supposed to be an x, so you replace the dx with that. Actually, let me just draw this again. So first of all, I have to fix that to a dx, and then this dx is now this du. So that creates a problem right here, because this is u to the 1/2, right? Dx is now du, but somehow there is an x right here. This is a big trouble. This is a big trouble. This is a du integral. You are not allowed to have x in there. So all the x must be cleaned up. But I am not able to do this. Should I move on to some other method? The answer is no. This is a very special case. When you see a situation like this, you have to do one more step based on the u. So you let u equals to 1 plus x, right? Let's change the variable a little bit. So what about you isolate x on one side by subtracting 1 on both sides? So u minus 1 is equals to x. Now we can do another replacement. We replace the x with u minus 1. So the integral becomes u minus 1 and then times u to the 1/2 du. Now this is correct. I have a du integral, and all the variables, they are u, they are not x. If you have an x there, you keep solving this, that means the whole thing will be all wrong. Okay, now let's solve it. So let's distribute the u. 1 plus 1/2, so that is 3/2, and then minus u to the 1/2 du. So this one, 3/2 plus 1 is 5/2, then this is a 2/5, minus this plus 1 is 3/2, 2/3, and then you add c to it, right? So at the end of the day, you put the u back, so that is 2/5, 1 plus x, 5/2, minus 2/3, 1 plus x, 3/2, plus c. How do you check your work? Just take the derivative of that. You can easily go back to the integrand. All right, so that is a very special case that you have to keep in mind. You use this when you are not able to clean up all the x from the du integral. All right, so that is the basic introduction to U substitution, or you can call this substitution rule. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help and support. See you all in the next lesson. Signing out for now.